Alright guys, so today we're going to be going over proportional relationships, and we're going to look at it in three different ways. We're going to look at it as a table, as an equation, and as a graph. So you have your foldable, you have tables, you have equations, and you'll have graphs. Now, proportional. What does proportional mean? So we're going to go over exactly what proportional means when you look at it in different ways, because what proportional means depends on how we're looking at the equation or the function and which way it's given to us. So with tables, we know a proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is equal or the same. All right. So what that means is that the ratios are increasing or decreasing by the same amount, right? So if we go from 1 to 2, we're increasing by plus 1. If we go from 60 to 120, that's an increase of plus 60. To go from 2 to 3, it's a plus 1. To go from 120 to 180, it's a plus 60. To go from 3 to 4, it's plus 1. To go from 180 to 240, it's plus 60. So hopefully we can see that if we were to take these and divide them, right? So like 60 divided by 1, because it's always going to be y divided by x. 60 divided by 1 is the exact same ratio as 120 divided by 2. 60 divided by 1 is 60. 120 divided by 2 is also 60. So the ratios are the same. This ratio is 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 the same. So we know that they're proportional. We can also see that because they increase every time the x increases by 1, the y increases by 60. When the x increases by 1, the y increases by 60, etc., etc. All right. As an equation, a proportional relationship can be written as an equation in the form y equals kx. Now they're going to write it down as kx. What I also want you to know it as is y equals mx. And m and k mean the exact same thing. So k and m both represent the slope. So m and k are the same. They both mean slope. Both mean this constant of proportionality or the slope in this case. So we need to circle all the equations that represent proportional relationships. If it is proportional, identify the constant. So hopefully we can look at these and we can see which equation is the odd one out. So 3 of these equations look similar, 1 does not. So I'll give you a little bit of time, give you 5 seconds to think over that, pause, and pick the one you think is not proportional. Okay, so once you've done that, we should hopefully realize by now that this y equals 6x plus 1 is the only one that is not proportional. So y equals 12x is proportional. Y equals 0.75x is proportional. Y equals 1/4 x is proportional. And the reason that is again, it's set up in the form y equals kx or y equals mx. So this has y equals mx plus 1. So this is having something added or subtracted to it. Okay, these do not, right? This is just something being multiplied by x. The constant is the number that's in front of x. So for instance, the constant for y equals 12x would be 12. So m equals 12. For y equals 0.75x, m equals 0.75. For y equals 1/4 x, m is equal to 1/4 x. For the third one, so looking at graphs, the graph of a proportional relationship is always a straight line that goes through the origin. So does the graph below represent a proportional relationship? So you need to ask yourself 2 questions. 1, is it a straight line? Yes, it is. 2, does it go through the origin? Remember, the origin is down here at the bottom at 0, 0. Yes, it does. So yes, this graph is proportional. Alright, so now we're going to look at this one, number 4. Dakota earns $8 an hour at his part-time job. Okay, so we have an x and we have a y. So we have to ask ourselves, x is the independent variable, y is the dependent variable. So the y depends on the x. So we can say Dakota earns money, right? he earns $8 an hour. So then our x value is going to be the time, right? The time that he works. And the money that he earns is the y value, because the money he earns is dependent for how long he works. The longer he works, the more money he's going to make. So after 1 hour, he should make $8. At 2 hours, he will make $16. We just double it. So at 3 hours, he's going to make 24. So then at 5 times 8 would be 40. At 10 hours, 10 times 8 would be 80. Right? And then we can graph that over here. We can now create an equation for this. All right? So we should hopefully by now know if my equation is y equals mx, I can find m, my constant, by taking my y value. So m is your y divided by the x. The change in y divided by the change in x. So in this case, I can just take 8 divided by 1, or 16 divided by 2, or 24 divided by 3. Any of those will work. So if I take 8 divided by 1, I get 8. So my constant of proportionality, my value for m, is 8. So we would write this equation as y equals 8x. And then the last one we're going to do is we're going to graph it. Now graphing, again, my x-axis, this is my x, so this is where I would put my time. My y, this is where I'd put the money. Okay, so we have to graph this according to how we would use it. So for instance, on time, I'm not going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't make sense, right? Sorry, for time I can do that. I can do, my bad, online. Time I can do 1, 2, 3, 4, 5. But for money, I can't do 1, 2, 3, 4, 5. I'm going to have to go, each line is going to have to have more value over here. So every 2 lines is going to be $10. So that's 5, 10, 15, 20, 25, 30, 35, 40. And then this one's going to be 1, 2, 3, 4, 5, 6, 7, 8, etc. So at 1 hour, he's going to make $8. And at 0 hours, he would have $0. At 2 hours, we would be at 16. At 3 hours, we would be at 24. At 4 hours, so 4 times 8 is 32. 5 times 8 is 40. So now we can get a graph that we can draw a line for. There you go. And that's all we're doing. So now you need to do the same thing for example number 5 on your own. If you have any questions, please let me know. And then after that, you will have an IXL assignment that you need to work on that is posted on Google Classroom.